For 1.6 here, we're going to solve some linear inequalities, which is probably one of my favorite things in all of Algebra 2. They're just so fun to do, so let's get started. Let's do this first one is a linear equation. So we're going to tie back to stuff that we know how to do really, really well. So if we're going to solve this thing on the left, this equation, how would you do it? Hopefully you all know that you would subtract 3 from both sides, and we'd have negative 4x is equal to 28. And we divide by negative 4, and we get x is equal to negative 7. Okay? Most of us probably have never done it before, but these solutions to equations can be graphed on a number line, and all that would look like is a negative 7 with a dot right there, just indicating that that one solution is right there. The inequalities are also graphed on number lines, and they have shading in either direction, so we'll need to be very aware of which direction we're going to shade based on the symbol and all of that kind of fun stuff. So how does our process change when over on the right we now have a greater than or equal to symbol? Really, not much is different. We still have to subtract 3 first. So we'd have negative 4x greater than or equal to 28. And we still divide by negative 4. But remember from Algebra 1, which was so very long ago, when you multiply or divide by a negative number, we have to flip the inequality symbol. So we're going to have x, flip the sign, less than or equal to negative 7. And then that's our solution. It's a whole range of numbers. Anything less than negative 7 works. So on our number line, we're going to put negative 7 there, and you're going to graph it. Maybe you remember from Algebra 1 with a closed circle. Why a closed circle? Right, because it's equal to. And then we're going to shade to the left because all of the numbers are less than negative 7, and less than is to the left on a number line. So that's pretty fun, right? Yeah, we're having a great time. So here, it's easiest if you graph like I just showed you above a number line. Okay, it can be on a number line, but it's just so much easier to read for you and for me if we graph above the number line like I was showing you in the last one. We can do open circles sometimes and closed circles. Open circles are when you have just less than or greater than. Closed circles when there's this equal to underneath of there. So if it can equal the value, then you want to close that circle. If it can't equal, then you want to leave it open. Okay, sometimes we shade left, sometimes we shade right. When the variable is on the left, if you always put the variable on the left, then that inequality will tell you which direction to shade. But not always, because if I had 6 greater than x, I would actually have to shade in the opposite direction. I'd have to shade to the left because x is less than 6. So if you always just keep your variable on the left, these symbols here will tell you which direction to shade. So be very careful with those kind of general rules that a lot of people like to use. Then the other difference we can have is and versus or. And inequalities always shade between 2 points, like this one did here, and or inequalities always shade away from each other. I say that's kind of like oars on a boat. So if you have an or inequality, it's like you're paddling a canoe with your oars or something sticking out each side. All right? So or, away from each other, and together. And those are the basic rules. As long as you can remember all of that, this should be a fairly fun section for you. Okay? So let's practice graphing. We have some ands and some ors all mixed up here. So let's see if we can figure out how to graph them. So this first one, I have x is less than 6 and x is greater than or equal to negative 4. So the two numbers I want on my number line are negative 4 and 6. Put them in the right order. The smaller one goes on the left, larger on the right, and that's the only two numbers I really need you to put on there. Okay? We don't need all of them. So 6, because it's not equal to, is going to have an open circle. And -4, because it is equal to, is going to have a closed circle. So you want to make sure that it's very obvious which one is open and which one is closed. So I should redo that one. All right, and then it's and, so we shade between. Okay, moving down. Now we have x is less than 6 or x is greater than -4. So I'm going to put my values on there. I'm going to put 6 and I'm going to put -4. Now, x is less than 6 is an open circle shading to the right, or to the left, sorry. X greater than -4 is a closed circle shading everywhere to the right. Now those two things overlap, right? That first one I graphed, open circle shaded all the way in this direction. The new one was a -4 shaded all the way this direction. So in an OR situation, we somehow managed to cover the entire number line. So our solution here is all real numbers. Isn't that like the coolest thing you've ever seen? So all real numbers for that one. We colored the whole number line. All right. How about the one on the bottom? X is less than -1 x is less than 6. So let's put our -1 and our 6 on our number line. X less than -1 is an open circle to the left. And x less than 6, that is an open circle to the left. Now, part of these are going to overlap. As soon as we hit -1, that is for both graphs. Because this was and, that's the situation we want to actually shade in for our answer. So I'm going to make our answer red here. Our answer is going to be an open circle shaded to the left. Okay, if we think about that, we're looking for numbers that are both less than -1 and less than 6. That means I can only choose the values that are less than -1. So this is your solution. The other stuff was scratch work. Okay, let's jump over to the right-hand side of our slide here. We have an 8 and a 6, so I'm going to put 6 and 8 on my number line. Both are open circles. X less than 6 shades to the left. X greater than 8 shades to the right, and it's an OR, and they look like oars on a boat. So those top two are kind of the quote-unquote normal situations. And these ones on the bottom are kind of weird because we end up with entire number line and one little branch. Kind of crazy. All right, our middle one over here, we have again our 6 and our 8. So we'll put those on my number line. X is greater than 8, so that direction. Open circle to the right. X less than 6 is an open circle shaded to the left. And now this said and. Well, can you think of any numbers that are both greater than 8 and less than 6? Of course not. That just isn't possible. So because this was an and not possible, we would say no solutions. That's pretty fun. All right, let's see what kind of weird thing happens on this last one. Now we have greater than 8 and greater than or equal to -4. So I'll put a -4 here on the left, 8 on the right. X greater than 8 is an open circle to the right. X greater than or equal to -4 is an closed circle, closed circle shaded to the right. And now we're looking for OR. So any number just has to be on one branch or the other. So our final answer will end up being, I meant to change that. Our final answer will end up being anything that we shaded in either graph. So it ends up being this red line because it can be either. All right, so sometimes super cool, weird things happen, and they're really fun. All right, let's try one real quick like. Okay, this equation, or this inequality, sorry, is an and situation. When they're smooshed together, it could also be written like this over here on the right. So it is an and situation. I kind of like them put together because then I can just work with it there and go about my life. So either way, we'll compare the two methods when we're done. So here it's important to note that there's like 3 different sections to this inequality. And whatever you do to one section, you have to do to all of them. So we're going to take note of this middle section here because that's where our variable is. Okay, so we have to get t all by itself. First things first, I think we should subtract the 4. And now notice I'm going to write that in all 3 sections. So here I get -5 is less than a negative t less than or equal to 2. Okay, now a negative t right there in the middle, that really just means I have -1t. So I need to divide everybody by -1. Okay, and when I divide by a negative, remember that fun fact, we get to flip the sign. So this is a +5, flip the sign to greater than, t, flip the sign to greater than or equal to, -2. All right, now it is a little strange to have the larger number on the left, so we can just kind of mirror image this and say -2 is less than or equal to t is less than 5. And then when we graph this on our number line, we want -2 on the left and 5 on the right. Closed circle at -2, open circle at 5, and shaded between because it was an and graph. Okay, here's what it looks like. If you don't smoosh it, leave it smooshed, you can separate it out like this, and that looks super fun. Okay, some of those get a little tricky, but I know you can handle it. If you have any questions, please let me know.